Okay, in this video we'll be discussing the hybridization of CH3OH. Now, there's a trick to figuring out what the hybridization of each atom is by simply counting the number of atoms surrounding the central atom and the number of lone pairs. So we could say carbon has 1, 2, 3, 4 atoms surrounding it, so it should be sp3, tetrahedral. This oxygen has 1, 2, 3, 4 atoms surrounding it. Well, 2 atoms surrounding it and 2 lone pairs, so that'd be a total of 4. And we know it's not tetrahedral, that's bent. And that is just a simple way of figuring out the hybridization. So this would be sp3, this would be sp3. The carbon and the oxygen are both sp3. But that does not explain why. So if you had a conceptual question, you'd be done for. Now, the reason why we hybridize is to conserve molecular geometry, and if we did not hybridize, our molecules would be really weird looking. It would not follow the bond angles and everything would be messed up. So let's go on with this. Okay, so carbon is 1s2, 2s2, 2p2. As you can see here, we excluded the 1s2, and the reason why is because it is not a valence electron. It is too close to the nucleus. It will not exhibit any bonding. So moving on, we can fill in our energy diagram right here. We have 2 electrons in the 2s, and we have 2 electrons in 2p, following Hund's rule and the Aufbau principle, you know, all those, Pauli exclusion, all that stuff. Anyways, we can see here we can bond on this 2px and we can bond on this 2py. Well, that's only 2 regions of bonding, and we have 1, 2, 3, 4 regions of bonding. So what we need to do is move one of these electrons up to this 2pz and hybridize all these orbitals to make sp3 so that we have 4 regions of bonding. And the reason why we can do this is because the gap between this s and this p is very small and it doesn't take much energy. So let's do that. So we bumped up a electron to here, and this hybridized all these orbitals, and so that is why it's sp3. If we only hybridized 2p orbitals, it'd be sp2. If we hybridize only one p orbital with the s, it'd be sp. Since we hybridize all 3, it's sp3. Now we can see here we have 1, 2, 3, 4 regions where we can bond, and that's great because that's what this carbon exhibits. So let's use this. This orbital right here is an s. This is a p, py. This is a px. This is a pz, and this is an sp, sp3 hybridized orbital. Now, when we do this, we're going to have to duplicate this because we have 4 sp3 orbitals. And a good way to make sure you're not losing any orbitals is to count these right here. We have 1, 2, 3, 4 orbitals. 1, 2, 3, 4 orbitals. That's just a good way to double check you're not making any mistakes. So let me just add these sp orbitals where they should be. It is very hard to show exactly what this molecule looks like on a flat piece of paper. So if you had a molecular modeling kit, it'd be a lot better to see 3-dimensionally. Duplicate one more time. Let's see here. There we go. Now we have all 4 sp3 orbitals, all the hybridized orbitals here. This right here in the center is our carbon, and we're going to put these 1s orbitals connected to these. The reason why is because hydrogen has 1s1 as its electron configuration. It only has the s orbital, so this s orbital is going to bond with this sp3. What you can say here is this bond right here is a S to a sp3 bond. So that's what that is right here. Just like these other hydrogens, I'm just duplicating this so we can finish building that. There we go. Now I'm going to move this structure because we're running out of room. So let's do that. Move this down here. Okay, just like these right here, that's a S to sp3. This is an S to sp3. So what is this oxygen? Well, we see here 1, 2, 3, 4. So that oxygen will also be hybridized. So we need more sp3 orbitals. So let me duplicate this. Take this over here. And I'm going to need 4. So duplicate again, and duplicate again. Okay. So this oxygen is going to bond by an sp3 right here. And let me keep filling in these sp3 orbitals. I'm going to have to move this out of the way. Let me just delete that. There we go. And our last sp3 goes right here. We have one hydrogen being bonded to an sp3, so let's take another circle here, an s orbital if you want to be specific. So there's that, and we can insert our lone electrons. Let me just duplicate these right here, and duplicate again, and right there. Okay. If you wanted to be very specific on knowing which bonds are which, this center bond right here is a sp3 to a sp3. So that's an sp3 bond right here to an sp3 bond. This bottom, like we already discussed, this sp3 to an s with these hydrogens. So yeah, that is what hybridization means, and conceptually you'd understand why we don't just count them, and that's the reason why. The reason why is because we allow more regions where we can bond, and it conserves molecular geometry. Keep in mind, this carbon is a tetrahedral, and this oxygen is bent, and if you would put in all of those angles, which isn't necessary here, we're just figuring out what is the hybridization of this molecule. I hope this video wasn't too confusing and it helped you, and that's it.